So before we move on, I want to do one more example with position, distance, and displacement, just so we get a better grasp on it. So consider the following problem. A car drives 6 miles east, then 12 miles north, and then 11 miles west. What is its final position, its distance traveled, and its displacement? Well, I'd say to start figuring out this problem, let's make a graph so we can plot where the car is as it's traveling. And we'll call this east, this west, this north, and this south, just like a standard compass. So the car begins by going 6 miles east. 1, 2, 3, 4, 5, 6. Then the car goes 12 miles north. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the car goes 6 miles east, then 12 miles north. Then the car goes 11 miles west. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the car will then drive this way, and it will finish right here. So now, what is the car's final position? So if we presume this to be the origin, so we'll call this 0, 0, its final position is going to be -1, -2, -3, -4, -5, and 12. So that is the car's final position. Now, for the next question, what is its total distance traveled? Now remember, total distance traveled is a scalar, and direction is not important. So in order to figure that out, all we do is we're going to add up all the individual steps that the car took. So first the car went 6 miles east, and the fact that it went east doesn't even really matter because, again, distance is a scalar, but so it went 6 miles, then it went 12 miles, and then it went 11 miles. So distance, which again we'll use d, is going to be equal to 11 plus 12 plus 6, which is 29 miles. And again, we can see this is a magnitude, and there's no direction, so again, verifying this is a scalar. So now the third question, the third part of the question is, what is the car's displacement? Well, remember that displacement is the net change in position. So the car started off here at the origin, and then it ended up here. So the net change in position is the length of this yellow line. Now, this is a little bit trickier to figure this out, but we can do this by saying that the displacement vector, which we use S, the reason why we don't use D or P for we don't use D because D is reserved for distance, and it's also used in derivatives, so it might get complicated later. And we also don't use P for change in position because P is used for momentum. So I believe S stands for spatial change, but that's what I've heard. It could be wrong, but as far as I know, we use S. Now, in order to figure out what the displacement is, we can make a right triangle and use the Pythagorean theorem. So if you're familiar with, you should be familiar with breaking a diagonal into its horizontal and vertical components. So let's do that now. So the change in just the total displacement is going to be equal to the square of the horizontal displacement, which we'll call x, and it's also a vector, squared, plus the y displacement vector squared, and the square root of that whole thing. And this is very similar to the distance formula. I'm sure that you've used that in either Algebra 2 or Pre-Calc. So what is the horizontal displacement? Well, the horizontal displacement is going to be -1, -2, -3, -4, -5. So we can say that the position vector is going to be equal to the square root of -5 squared plus, well, let's see what the horizontal change is. We could count these, or we can just look at our coordinates and know that the total, I'm sorry, did I say horizontal? I meant vertical. And we can see that the total vertical chain is going to be 12 miles. So we can say plus 12 squared. And then now it's just a little bit of math here. The square root of 25 plus 144. And that's equal to the square root of 169, which is equal to 13 miles. So its total displacement is going to be 13 miles. Now, it's also noted that this is a vector because it does have direction. The direction is somewhat north. I'm gonna use this tentatively. I'm gonna say somewhat northwesternly. It's not completely northwest because northwest is right in the middle of north and west, and this is a little bit more north and west, but it's somewhere in that direction. But you can clearly see that this does have a direction, and that's why it is a vector. So our total displacement is 13 miles in a somewhat northwesterly direction. So now hopefully we get a better feel about how displacement, distance, and position all work together, and how scalars and vectors are different quantities and how they each play into what we're calculating. Anyway, see you next time.